still here at Fobeni High School, and we're about to find out what our first learner question for today. Remember, we're dealing with mathematics. Yes, Shai Bal, 1, 2, 3, 4. Franami, salute to you. Let's find out who's asking our first question. Tawelausi.
Aye.
Or Abshin.
Aye.
Oh, same response.
Yes.
Okay, what's your name? How old are you? Where are you from?
My name is Lilian. I live at Mapidula village. I am 22 years old.
And you're doing grade 12 here at Fobeni High.
Yes.
All right. So what is your learner question for our teacher in the studio?
What is the meaning of a gradient of a curve at the given point?
What is the meaning of a gradient of a curve at a given point? That is the question. Over to you in the studio.
Yes, it says, what is the meaning of the gradient of a curve at a given point? Now remember, girls, how do you find the gradient of a line? Remember, it's the y equals mx plus c. So it's, the y2 minus y1 over x2 minus x1. But the problem now is, if you've got a parabola, how do we find the gradient of a parabola at a point? Very simply put, if you think about a car, you're in a motor car and you're heading down to Durban, let's say, to Durbs, and you get in your car. Do you agree your speed is changing? Yeah. Now, very simply put, guys, your speed of your car is actually your gradient. They call it a rate of change. Now, do you agree that you can, on average, last lesson we spoke about average gradient, you work out between two towns, that you can work out your average speed. It's always changing. But the moment, it's when that camera hits you, as that camera captures you, as you go 160 in a 60 zone, then you know that's the gradient. Okay, now how do we do it for a parabola? We're going to work out gradient from first principles. Okay, now have a look at this. If we go here, we're going to take an example of a little parabola. It's one of these sad guys. If you remember, Amanda and I were talking about this. It looks like this. If you remember, Amanda, we spoke about that. Hey,
oh yes. It's
a sad chappy, and we want to see the gradient at x somewhere on there that x is -3 using first principles. So they give you that curve. Now, how do we do it? Have you done a bit of calculus at school? So you know about first principles. Okay, let's see. Carol and Precious, if you're going to master this. Okay. Do you remember the formula? The limit as h approaches 0, fx plus h minus fx of h. They give it to you on the formula sheet, but of course, you must know this, because how do we use it? Now, don't make mistakes. Okay, let's see if you girls know how to do this. Okay, here we go. Now can you notice that I've got a little plus h there? Okay, now take your original curve, which is -2x squared plus 3. Now what we do is we go and we're going to give him some supplements. Okay, this graph is going to go to gym and he's going to pump up his muscles. Okay, and he's going to become, we say in maths, hunky. H for hunky. Now watch this. If you have a look here, now watch this. Now he's getting a bit bigger. You see all these muscles here? To his muscles that are very exy in maths. We could say sexy, but we mean exy here. Okay. All right. Now we're going to add to his muscles. Now watch this. The H. Whoa, he's getting good looking, girls. There he goes. And we add H. Okay, so we add H to all the X's. Are you with it? And then what do you think we can do now? Precious? What would you say?
Okay, I think we should substitute to the formula.
Absolutely, brilliant. Hey, this is brilliant. We're going to do that. And the way we do that is exactly that. Look, there's a red one and a blue. Okay, the blue is your original. Do you agree? And the fx plus h is what we already worked out, you see. Now, precisely what Precious did. I didn't even prime her. I didn't even tell her about this. You can see. Carol, what do you think? Okay, what are we going to do? Do you agree with Precious here? Now watch this. This is so romantic. Check this. It's going to go here. This one is going to go into the red one. Okay, we move it. There it goes. I'm going to put him just on top there, and then the blue one on top there. And what do we do with that? As Precious said, we substitute them in. So what is actually going to happen is this guy goes there, and that guy goes there. But remember, there's a minus before brackets. Okay, you're subtracting that whole thing. So well done. You can see this, the girls in studio are good today. Okay, now watch this. Now when we've got them in there, the most important thing is to multiply these out. Now be very careful. X plus h all squared is not x squared plus h squared. It's two brackets. Do you remember? FOIL, firsts, outers, inners, last. It's like a dance. Come on, let's do it. Wah, 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 wah. It's a firsts, others, inners, lasts. Okay, now remember, how did we do that? If you got stuck, you know, many matrics battle with this. Okay, x plus h squared. Listen, if you remember the shortcut, how do we do it? We square the x, we multiply x and h together and double, giving you the 2xh, and we square the h. But if you don't like that, look at this. You've got two brackets there. Do you remember this thing? It goes, and you can go first, others, inners, lasts. And you do that. And then don't forget here, you must multiply negative times a negative is a positive, and negative times a positive is a negative. And then what happens here? This is quite interesting. Well, if you multiply negative 2 with x squared, negative 2x squared, negative 2 times positive 2, negative 4xh, and then negative 2h squared plus the 3, then we times out negative times a negative positive, and negative times a positive negative. Everyone happy? So you've multiplied that out, okay. And what's so wonderful, anybody that's not hunky here, we're going to get rid of them. You don't have an h in you. Haha, bye-bye. 3, bye-bye. And look at that, we're left with this, all the h terms. Of course, you can't say that h equals 0. Do you agree? Because that's division by 0. Now, what actually happens, here's a very interesting little principle. What you're doing is when you get this, we can take out an h. Do you see that? We can actually factorize the h out. Okay, and we can cancel those h's, and we're left with this. Now notice you've got the equals and the limits going down. Okay, make sure of that. Now, people, very, very important. Do you notice something? And this is maybe what that you don't know. H is approaching 0. Do you agree? Does it equal 0? No, because listen, you can't, this is something that's very important. H is never equal to 0. But we're approaching 0. So what do we do here? Now be very careful with this. This is something that most people battle with, and guys in Mzansi, listen to me. For the matric final exams, be very, very careful here. I want you to state that h doesn't equal 0. So write that down. We are approaching 0. There's a massive difference between approaching 0 and equaling 0. Now what happens there is this guy. If you approach 0, let's suppose you're getting from, let's say we're coming down. You got 0,1, then it's going down 0,001. You're getting closer, 0,00001. You never really get to 0, but you're approaching. So what actually happens if we approach 0, this guy here is getting so small. Do you agree? So what we can do is we can kind of ignore it. We actually ignore it. So what is actually happening there, if you think about it carefully, is that we ignore that. Remember, h is not equal to 0. We're going towards 0. It's approaching. So 2 times a number that's so close to 0 is so small that it's negative 4x, and there's a little eensy-weensy little number there on the end there. So we kind of ignore it. It's 0,0000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 it's approaching naught. So very important, always remember to say h can't be naught, we're approaching it, so that piece disappears. Anything with the h disappears, it's too small. It's actually there, eensy weensy, negative 4x and a little eensy speck of a number. Okay, it's getting too small. But don't go and say negative 2 times naught, because it's not really that, it's actually approaching it. So we get to negative 4x, but really if you think about it, it's 2 times 0,0, it's almost naught. It's approximately that. So that piece vanishes.
So you should never really replace the h with a
no,
with a
so
zero.
don't say h equals naught. Okay, so that's not strictly correct. One might argue, but hang on, you know, it's disappeared.
Yeah,
so it must be naught.
if you substitute, it disappears.
Yeah, but strictly speaking, do you know what's actually happening here? It's actually getting closer to naught, and it gets so close that it's getting so small. You know, it's getting, you know, that distance between h is naught, it's going. So it's there, but we never really get to naught, but it's so small. So, but don't panic if you're stuck and you want the marks. Just say h is going to naught, so that disappears. Scrap that, because it's going to naught, it's approaching naught, and there we go, you see. And then people, that's called the gradient, and if we want the gradient at negative 3, it's going to be negative 4 multiplied by negative 3, which is 12. And what does that mean? Well, very simply put, if you look at the parabola, I've drawn it there. Well, if you think about it, let's just go back there quickly. Very simply put, at x equals negative 3, your gradient is this. The gradient is going to be 12 there, you see. And that would be like mx plus c. That's a line. So the gradient is 12, which is the gradient of the curve. Okay, itself. Okay, you got it?
Yes, I got it.
Cool.
That's sasekhona la eFobeni High School in Fobeni Village in Limpopo. It's still Limpopo, and it's not Mpumalanga.
No, it's Limpopo.
You see, we've been traveling so far, so wide, so long. Me, I've lost track. I thought we were in Cape Town. All right, but we are here in Fobeni Village, and we're about to find out what our second learner question for today is. Hey, Dibra.
What about?
Absheng.
Nifukeni.
I sure. Nami nifukile. Bengilele ngavuka. All right. Ungubani wakabani? I was introduced kubantu lapha ekhaya.
My name is Rulani Mashaba, better known as Mr. Him is me on Mixed. Whatever. I'm a grade 12 learner at Fobeni High School.
All right. Better known as Mr. Him is me on Mixed. Hope you're visiting South School on Mixed. You are, ne?
Yes, I do.
Okay, cool. What is your learner question for today?
My learner question for today is what is the relationship between the first principle and the differentiation?
Okay, guys, relationship between first principles and differentiation. In an exam, they always ask you one question on first principles, but there's a much shorter way. Do you know that they're the shortcuts? They're very easy. Now, let me have a look here. The rules of differentiation are very, very easy to follow. Okay, now watch this. The first rule, remember you're getting the gradient. It's exactly what you're doing when you're doing first principles, but that's a long limit as h goes to naught method. Now watch this. The first rule, if fx is ax to the n, like for example, let's have a look at this here. Let me make up one quickly here. Say you had fx is equal to 3x to the 9. Okay, the gradient is very simply put, what you do is you go 3 multiplied by, bring down the 9, x to the 9 minus 1. Do you remember that? It's rule 1. A, you keep the a, bring down the n, and then you subtract 1, which comes to 27x8. Now, the next rule also works like this. Now, watch this carefully. The second rule says, if you've got ax but no n, okay, that's like y equals mx plus c. That is actually very simply a gradient, you see, of a line, which is the number next to x. What is the gradient of y equals 2x? Is 2. You see, it's the gradient of a line. So if it's ax, your answer is just a. And then rule 3 is easy. If fx is a number, the gradient of 0. Think of a horizontal line. What's the gradient of a horizontal line? 0. Okay. Now, if you have a look, if you just quickly look at this, I want to show you something here. When you took that curve, fx is equal to negative 2x squared plus 3. Do you remember that was from first principles in the previous lesson? The gradient came to negative 4x. That's what we did. Do you remember? Now, if you look at rule 1, you bring down the 2 and subtract 1. Look at that. Negative 2 times 2 is negative 4. And then you got 1. And then the 3 goes to 0. Isn't that cool? Okay. And here's an example. If you look at this one, the gradient, if we go look there, what would it be? Let's just have a look here carefully. So the gradient would be, okay, negative 2, bring down the 2, subtract 1, plus 0. It's the same as doing first principles. You only do it when they say first principles, okay? Very, very cool. And then have a look at this one. What's the gradient there of that line? Y equals 3x?
3.
Yeah, the gradient is 3. So the gradient there is going to be 3. So you simply go like this. F prime x is equal to 3. Isn't that cool?
Quite
yeah,
quick.
what a pleasure. Okay, and then watch out for this one. The typical exam question that they can ask you is, with this one, very simple. Use the little Mediba rule here. Do you remember the Mediba rule? It says 4 over 3, and then this is x to the 3 over 4. Do you remember that one? 3 over 4, and then you say y is equal to 4 over 3, x to the negative 3/4. Bring that up. See there? And then you use the symbol dy dx. And how does that work? So you've got 4 over 3. You bring down the negative 3/4, or running out of space there, x to the negative 3/4 minus 1. Okay, and you subtract that, and then you get your gradients, okay, of that. All right, so that, remember, bring it up, get it a x to the n, and then 4/3, bring it down and subtract 1. You got it there.